In the previous videos, we have studied various properties of a sound wave. Here we will talk about one more called the speed of a sound wave. Speed is that physical quantity that defines how fast some objects travel. We all are aware of general formula of speed of any object. What is it? Speed is the distance in a given amount of time. Speed of a sound wave is defined as the distance travelled by any point on a wave per unit time. What does it mean? It means that if I take any point on a wave, suppose this one, the point of maximum density, then the distance travelled by this point in unit time is speed of a sound wave. In terms of SI units, the speed is the distance travelled in meters by any point on a wave in 1 second. There is another way in which we can find the speed of a sound wave. We think of the speed of sound wave in terms of one cycle of a wave. When does a sound wave cover one cycle? When it moves from maximum compression to maximum rarefaction back to maximum compression, we say that one cycle is completed. What's this distance then? We have seen previously that this distance is nothing but the wavelength lambda, and the time required to complete this distance is time period t. So we can think of the speed of a sound wave as the distance travelled by a wave equal to the length of one cycle over the time required to complete that distance. Hence the speed v is the wavelength lambda over time period t. Yes, it's the wavelength over the time period. Do you remember what 1 over t is? We have seen in our previous video that this is equal to frequency nu. Now replacing the 1 over t with nu, we get v equals to lambda nu. This is called the wave equation. This is true for any type of wave and not only for a sound wave, which is a longitudinal wave. The wave equation gives us the mathematical relationship between the speed of a wave, its wavelength, and its frequency. Let us do one easy example based on this concept. Read the question carefully. First, let us see what we are given. We are given the frequency of a sound wave. We can say that nu is equal to 220 Hz. The speed of sound is equal to 440 meters per second. Before moving on to solving any problem, we should check if all the units are uniform. We see all the units are SI units. We are asked to calculate wavelength, that is, we are asked to calculate lambda. We will use this formula, which is nothing but the wave equation we just saw. V equal to lambda times nu. Substituting the values will give us this. Dividing both sides by 220 will give us this equation. Finally, we get the answer as 2 meters. Don't forget the unit of wavelength. Sometimes during the rainy season, we see the lightning first and then hear the sound of thunder. What do you make of this phenomenon? This tells us that speed of light is more than the speed of sound. There are some factors on which the speed of sound depends. One of them is the temperature of the medium. The speed increases when the temperature of medium increases. The speed of sound in air at 40 degrees Celsius is approximately 355 meters per second. And at 20 degrees, it's around 344 meters per second. The other factor it depends on is the medium itself. In which case do you think the speed of sound will be higher? Solid or gas? The speed of sound is more in solids than in gases at a particular temperature. That's correct. Sound will travel faster if the medium is a solid. Have you heard the term supersonic speed? Do you know what it means? When the speed of any object exceeds the speed of sound, we say that the object is traveling at supersonic speed. Have you ever heard about supersonic missiles such as the BrahMos or the supersonic aircrafts such as the Dassault Rafale? Yes, those are missiles and aircrafts that travel with speeds greater than that of sound in air.